Welcome everyone. We are 4 members. We've done a project in emerging methods for early detection of forest fires in the domain of artificial intelligence using deep learning. Uh, as our team members were Guna, SHEKAR, Naga, MAHESH, Yahoshuva, and CHETHAN. And here we're having a problem statement. It defines a large destructive fire that spreads over the forest or an area. Woodland is a forest fire that causes a loss of humongous amount of property, wild, ecosystem, economy. The project is focused on creating a permanent solution for this problem. As you see the main theme of this problem statement, we can observe the forest fires department and by deciding of the forest fire quality, and it requires more thermal cameras, and it is not possible to detect forest fire quickly and stressed and agitated. And we can see the proposed solution statement. We're having to find the emerging methods for early detection of forest fires using artificial intelligence. As I mentioned before, we done this project on the domain of artificial intelligence using deep learning model, and we have the description. This technology is to be implemented to locate a forest or bush fires based on the concepts of deep learning. After detecting, and authorities are to be alerted immediately, mitigate any damage. So the so now I can see the technical architecture behind this project is we having a video feed frame camera using deep learning model. We extract the frame from videos, and through deep learning model we detects the forest fire detection signals through alarm, and we get the video frames from the sensors. So this is the main concept of the technical architecture behind the project. So now we coming to the working demo. As we discussed before, the working demo is proposed structure of the code which we can see on the screen. Now we're going to run this code. As it runs, as you find the required output. So this code we can use this code to exhibit the featured output of the emerging early fire detections. And as you see the model fit generators from approach 1.5 and 40.5, and this you can find the accuracy also. There you can find the exact levels of accuracy with the several levels of approach and model saves and ITRAS JVC images classifications and new tags. So as you go down, you can find the datasets over here. As I share the screen, we can find the model and compiles and models and fit generators and approach. As you see the frequency of these approaches and accuracy of these datasets and requirements and already satisfied. So as you go down is the model compilations and the model fit generators. We can find about the datasets, and before implementing the datasets that implementing the datasets, we can see the functions of the imports. As we see the as we see the code, we first import Keras, and from MATLAB import pilots as a PLT, and from Keras processing image input as an image data generator. So as you come down, import OS and types. As you import the pandas as a PD, and from the bootcamps and clients import configurations, and you find a required code behind this. And now we come to the import of byte IOs and zip files. As you see, the important of this code is to model to be generated and an important sequential of Keras layers. As you now we see the code of how it runs. So so it shows success as you can see on the screen. It shows the success. Just we'll give another run. See, you can clearly observe the outputs of this working model as a forest fires, so that we can conclude for this working demo. As you see in our above code and the data sets required for this preparation of the document for the project, we can clearly see the output of the forest fire. And now, coming to the performance metrics, as you clearly observe the as I mentioned before, you can find the accuracy of the project. Now you see the performance matrix as I before mentioned. It's clearly showed the accuracy of these documents and shows. This is all about my project, and you can see the future scope of this project. The applications can be enhanced by the training the model with the large datasets consisting of files and various stages of dimensions. With the higher GPU memory, and we can use two deep learning models for feature extractions, whose output feature vectors are concentrated and classified to offer more robustness. And as we used a CNN model in this project, we can in future we can use a regional based CNN model can be used to implement the fire localization along with the classification. We can also expect better deep learning architectures to emerge in the future. So before using RCNN, regional based CNN, offering better feature extraction, the application will be also offer a considerable better performance. When runs on the machine, having a better processing power compared to the existing one of the which is added to be developed. So this is all about the emerging methods for emerging methods for early detection of forest fires. So this is all. Thank you everyone.